Welcome to our final network security project presentation. In this project, we designed and implemented a secure network infrastructure based on our own university, the International IT University. The network consists of two campuses, the main campus and the Bayzak campus. These campuses are interconnected via a site-to-site IPsec VPN tunnel, which ensures encrypted and secure communication between them over a public network. The main campus and the Bayzak campus both employs the layer 3 switch for inter-VLAN routing, and they use a router on a stick configuration for inter-VLAN communication. All critical core services such as DNS, FTP, and NTP are centralized and hosted within the main campus server room to ensure availability and simplified management.
VLAN configuration. We started by segmenting the network into multiple VLANs to improve security and reduce broadcast domains. Specifically, VLANs 10 to 50 were created for the main campus, and VLANs 60 to 90 were set up for the Bayzak campus. To support this segmentation, we configured two different types of interfaces: access ports connection and user devices like PCs and printers to their respective VLANs. Second, trunk ports, enabling VLAN traffic to traverse between switches and routers while preserving VLAN tagging. Inter-VLAN routing. For routing traffic between VLANs, we implemented the router on a stick method on routers in both campuses. This technique uses a single physical interface configured sub-interfaces, each assigned to a VLAN, which simplifies hardware requirements and facilitates secure inter-VLAN communication. Also, you used this single routing approach. It proved effective in enable seamless and secure data exchange VLANs within the campuses. And so, STP, port security, VLAN security. To enhance layer 2 network resilience and security, we applied several important measures. Spanning tree protocol was enabled to prevent switching loops, ensuring network stability and redundancy by dynamically blocking redundant links. Port security was configured to restart switch port access to a predefined list of MAC address, protecting the network against unauthorized devices and MAC flooding attacks. We also implemented VLAN security best practices, including disabling unused ports and assigning them to a black hole VLAN, effectively isolating unused physical ports to prevent potential unauthorized access.
Here I'm talking about the DHCP for efficiency IP address management. This DHCP service were configured on both routers to serve dynamic IP addresses for each VLAN. For each VLAN, it has a dedicated pool. DHCP will appropriate IP addresses, ranges, and exclusion default gateway in our DHCP pool. And after deployment, the internal DNS server to distribute DNS server IP to clients, ensuring that devices receive the correct DNS setting dynamically or domain name resolution. The next one is a site-to-site IPsec VPN and ACL firewall. To secure communication between campuses over public internet, we establish a site-to-site IPsec VPN tunnel to utilize ICPKM policy and apply access lists for our key exchange and IPsec for data encryption. We carefully configure the crypto maps for the two campuses routers and restrict the traffic flow strictly to authorize the traffic flows strictly to subnet and minimize the attack services. Additionally, we ACL function as a basic firewall on networks interface, blocking unauthorized inbound traffic and protecting internal resources from the external threats.
On server 0, we are going to deploy DNS service that results in university-specific domain name www.IITU.edu.kz. But for that, we have to exclude the server IP from the DHCP pool. Then we have to change the default 8888 DNS server address in the DHCP IP address pool. Also, I have to activate the disabled Fast Ethernet 03 interface to grant access to the server. Now we implement the same logic to the second part, but we do not exclude the address because it is not founded in the DHCP pool of the second part, which is the Bayzak campus, because it belongs to VLAN 50, the management VLAN in the main campus. Good. We reactivated the DHCP and we can see that the DNS server address has been changed. Now let's test for connectivity of the DNS. And also we have to add the record. The name would be www.iitu.edu.kz, and the address is the same address of this server. Which other components like hosts, computers, and devices can found this DNS server and also use the domain name service. It is configured very well. Now let us check for connectivity. First, let's ping the server itself using the IP address. It's working, so let's try the domain. Actually, the domain name service it just translates the IP address to the domain, and vice versa. So we're pinging the same object, the server. Everything should do fine. Yes, it's working perfectly. As you can see, the reply came from the same server. That is the use of DNS. After the DNS, I'm going to configure FTP. The FTP server. The FTP server was enabled on server 0, and the test user account was already created by default to demonstrate the capabilities. As we showcased a simple and basic FTP command from a client PC that is called PC0, using the command line to manipulate the files between the server and the host itself. First, I used dir to check the directory of the server, and now I choose the first file to get, but it takes a lot of time for the FTP to transport the file, so we're gonna skip it for now. As we have the domain name, we're going to configure AAA standard and SSH secure shell. To strengthen the network security, we implemented AAA authentication, authorization, and accounting using the AAA new -model command with local user authentication configured. Also, SSH access was enabled on routers and switches with RSA-K pairs being generated and associated with the university domain IITU.edu.kz. And remote access was strictly limited to SSH, which are the VTY lines, the virtual lines for remote access, so you don't have to use a console line to configure the device, preventing insecure protocols like Telnet from being used. Thus, it enhances the confidentiality of administrative access. Now we're going to apply AAA and SSH to the main devices, the most important devices such as routers of our main campus and Bayzak campus, also the multi-layer switches for those campuses, of course. And next, we're going to enable NTP, Network Time Protocol. To maintain accurate and synchronized time across all network devices, we configure the Network Time Protocol server on the server 0. All routers and switches should be synchronized to this NTP source. Now we're going to showcase the NTP service on the main router of the main campus, which is critical for consistent timestamping of logs, ensuring reliable event coloration and audit trails for security monitoring. Excellent. So the time source is NTP, and the source of it is equivalent to the IP of the server, which means the NTP is working perfectly. So it's time to conclude. This concludes our network security project presentation. Throughout this project, we successfully designed and implemented a comprehensive network infrastructure incorporating essential security and management services. From VLAN segmentation and secure VPN tunnels to DHCP, domain name service, file transfer protocol, AAA, and time synchronization using NTP, our implementation demonstrates a robust and secure environment suitable for a modern university network. Thank you for your attention, and we are happy to answer any questions you may have.